Topic for this video is one of the most fundamental topics of statistics, that is sampling. In this video, we'll be covering the introduction or the definition to what sampling is. Then we'll be covering what is the difference between population and a sample. Then we'll delve into the need for sampling. Why do we need sampling in the first place? And also look at some of the major sampling techniques. Now let's start by introducing what sampling means. So sampling refers to the process of selecting a subset, star marking this particular keyword, subset of observations or data points from a larger population for any analysis. Let's try to decode this. What this means is, let's say this is a city, right? This is a city, and in this city I have, let's say, 500 people. That is the whole population of the city. Now selecting, let's say, 50 people out of this city, that is a subset of 50 people, is known as sampling of the overall observations. I am trying to subset a few people, that is out of the 500 population I am trying to subset a few people, which the process of subsetting is known as sampling. Sampling also involves carefully choosing a representative group of individuals or items from the population to draw conclusions or inferences about the entire population. Draw correct inference, right? Now let's try to understand this with a better example. Now let's take a use case wherein we are asked by the government of India to calculate the average income of the overall population of India, right? The population of India is 1.4 billion, right? Obviously, I cannot go to each and every person of that humongous population and ask for their incomes and then average it out. So I'll take the second route of sampling. The first point in sampling was, in the definition of sampling, was subsetting, right? That we star marked, subsetting the overall population or the observations. In this particular case, the observations are the people. So I'll subset, let's say, 10 lakh of people from the overall population of 1.4 billion. That was the first point, that is subsetting, right? That we saw in this particular definition. The second point, what it says is carefully choosing the representative group of the individuals or items from the population. That is, the sample, the subset that we have chosen from the population should represent the population. What do we mean by this particular thing? Now let's say for the second point, we know that the population of India, the 1.4 billion people, 70% of the people are service class and 30% of the people in India are, let's say, business class people. So our purpose over here for the subset that we have chosen from the overall population, that is 10 lakh, it should be chosen in such a way that in this particular case also, of the 10 lakh people, 7 lakh people should be in the service class and 3 lakh of the people should be belonging to the business class. This is how, or what is meant by the sample or the subset should represent the overall population. If it would not represent the average income that we were trying to infer from the sample regarding the overall population, that would be incorrect, or the analysis that we were trying to do or the inference that we were trying to make out of the sample would be incorrect. So this is what is the definition of sampling. Coming to the difference between what is a population and a sample, right? So population refers to the entire group of individuals, items or events that you want to study or draw conclusions or inferences about. Referring to our example wherein we were tasked to get the average income of the population of India, that is 1.4 billion people or individuals, right? The overall population for us in this particular case would be these individuals or 1.4 billion people, because we wanted to get the inference in this particular case was the average income of the population of India, right? This was the population in our case. The population is also called as the complete set of possible observations or the superset. The superset over here is 1.4 billion people in India. Coming to sample, a sample is the subset of the population that is selected for the study and analysis. That is, we are trying to infer about the population using a subset of that particular population. That is called a sample. Coming to that example again, we subsetted 10 lakh of people, right, from the 1.4 billion population, right? This is what a sample was. 10 lakh of people subsetted from 1.4 billion population of India is what a sample refers to. The second thing that we learned about sample is a sample is chosen to represent a larger population and provides insights or make inferences about the whole population. So since we want to make inferences about the whole population using a sample, it should be representative of the sample. As we saw, that if there were 70 is to 30 ratio in the overall population, service versus business people respectively, the same ratio should come into selecting the sample as well. Of the 10 lakh people, 7 lakh people should be from the service class, whereas 3 lakh people should be from the business class, because we want to infer the characteristics of the population using a sample. This is what sample difference between the population and a sample is. Now, coming to the need of sampling, or why do we need sampling in the first place? The first and most important advantage of using sampling in inferencing a population is its resource efficiency. That is, it conserves resources such as time, money, manpower, making studies feasible and cost effective, right? If let's say I were to average out the population, that is the income of 1.4 billion population in the entire India, it would take me a lot of time, it will take me a lot of manpower and money to go and ask each and every person or collect the data of each and every person with respect to their income and then average it out, right? So sampling 10 lakh of people and only inferring them instead of the 1.4 billion population makes it resource efficient. Second thing is practicality. The second advantage is practicality. That is, in many cases, studying the entire population is very impractical or impossible due to many constraints such as its size, geographical dispersion, or any other constraint, right? In our particular case, since we have a very large population in India, that is 1.4 billion people, it will become highly impractical, or in other words, impossible to collect each and every person's income data and then average it out for inferencing. Is why we do sampling, which will which will remove the impracticality factor of doing such a task. The third advantage of sampling is its time efficiency. That is, conducting research on a sample is often quicker than studying the entire population. Obviously, if I were to study, infer, and get the data of 1.4 billion people versus the data and inferencing of just 10 lakh people, that is a subset of the whole population, it will be time efficient. Coming to the fourth advantage of sampling, that is its power of statistical inferencing, right? If the sample that has been chosen out of the population represents the overall population perfectly, the inferencing that we were to do or the conclusion that we were to make of the overall population would exactly or approximately match that of a sampled population. That is, in our particular case, if the sample of 10 lakh people from the 1.4 billion population of India, if that particular sample was the correct representative, that is 70% of the 10 lakh people were service people and 30% were businessmen, the average income would be approximately equivalent to the whole population. This is the power of sampling, that it does a correct statistical inferencing. Now, coming to what are the major sampling techniques, there are four major sampling techniques, namely random sample. That second one is stratified sampling. The third one is clustered sampling. The fourth one is systematic sampling. We'll delve into each one of them one by one in depth. Coming to the first strategy of sampling or type of sampling, that is random sampling. What is the meaning of random? Random means without any method, right? No method or no strategy to do the sampling. In random sampling, every member of the population has an equal chance of being selected from the sample, right? Since there is no method, there is no strategy for choosing, every member has an equal chance of being selected. Let's say we have a box containing 10 balls. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I were to ask you to pick any ball from this particular box without applying any brain, randomly, without any strategy, what is the probability of this ball being selected? It is obviously 1 by 10, that is 0.1 probability. What is the probability of this ball being selected? That is 1 by 10 again. So each and every ball without any strategy, if I were to pick any ball randomly, the probability of each of these balls, any of these balls getting picked is 1 by 10, which is equal, is what is meant by random sampling, right? Advantages of random sampling are it eliminates selection bias, ensuring representativeness, and provides a basis for statistical inferencing. As we just saw, it is synonymous to what we just saw, that is equal representation of each and every element. The probability of any element being picked up is equal all across, is how the random sampling eliminates the selection bias and ensures the representativeness of each and every element in the particular population. One of the disadvantages of random sampling is it can be impractical or difficult to implement in large or dispersed populations. For this, let's take the example that we already saw, wherein we had a big population, that is 1.4 billion population in India, and we had to get the average income of the 1.4 billion population. Right? In this 1.4 billion population, we had 70% servicemen and 30% businessmen. We took a sample of 10 lakh people, right? Since it's a very big population and it is a dispersed population, there, if we use a random sampling over here, there is a chance that the sample that we took out is not a representative of the overall population. That is, let's say we get a 80-20 split over here, that 80% of these, that is 8 lakh people in the sample, are service people, and 2 lakh, that is 20%, are business people, which is not a representative sample or representative of the overall population, which will make the conclusion or the inference wrong. This is one of the advantages of random sampling. Applications of random sampling are it is widely used in survey research, opinion polls, and experimentation studies where representativeness is critical. By representativeness is every sample has an equal chance of getting selected. Now coming to the second technique, that is stratified sampling. So stratified sampling divides the population into distinct subgroups or strata based on the certain characteristics, then select the samples from each stratum proportionately. Let's try to decode this. Let's say we are in a country, let's say India itself, but in this particular case, hypothetically speaking, we have only 3 states in India. 1, 2, 3, right? Our task is to calculate the average age of the overall population in India. And the overall population in India is 1.4 billion. Hypothetically speaking, let's say we have only 3 states in India. In the first state, we have 50% of the population. In the second state, we have 30% of the population. And the third state, we have 20% of the population. Now, what stratified sampling does is it divides the population into distinct subgroups or strata. In our particular case, these are the 3 different subgroups, that are the 3 states which are also called as the strata based on certain characteristics. What are the characteristics? That each of these states have a different percentage of population in them, right? 50% of the population resides in state 1, 30 in 2, and 20 in 3 respectively. Now what we do is we sample the whole 1.4 billion population. That is, we take out a sample of, let's say, 10 lakh people, right? But this 10 lakh should be sampled in such a way that each of these states have the proportionate number of people as compared to the population. What I mean by that is, since in the overall population, state 1 had 50% of the overall population, the sample should also have 5 lakh people selected from the state 1, right? Similarly, 3 lakh people from the state 2 and 2 lakh people from the state 3. This is what is meant by selecting observations from each and every strata or the subgroup that we have created of the overall population in a proportionate manner so that it represents the overall population. This is what is meant by stratified sampling, which is used when we don't want to use the random sampling because the overall population or the population diversity is too big, and hence we use stratified sampling in this particular case so that the sample is representative, ensuring that the sample is representative of the overall population. Correct. Advantage of stratified sampling is obvious that it makes sample more reflective of the overall population diversity. Right. Since India has a large population of 1.4 billion people and the population is very diverse, we cannot use random sampling because one of the disadvantages of random sampling is it cannot be used on such a big population because there are chances that the sample chosen using random sampling on such a big and diverse population cannot be a representative of the overall population. Is why we use stratified sampling so that we have the representation of each of the states, the percentage population distribution in each of the states, we have the correct representation in the sample as well. This is one of the advantages of stratified sampling over the random sampling. The disadvantage of stratified sampling is it requires prior knowledge of the population. That is, what I mean by prior knowledge is, in our particular case, we needed to know how many states does India have. That is, if I need to divide the overall population of India with respect to the subgroup that is states, I need to have the prior knowledge of that particular country or the population. And then secondly, I need to have the knowledge of what percentage of population, overall population, resides in each of these states, right? This is the prior knowledge that I need to have regarding the characteristics of the population, in our case India, and also regarding the subgroups, that is the states in our country, in our particular case. So as compared to random sampling, this stratified sampling becomes a bit more complex and time consuming. This is one of the disadvantages of stratified sampling over as compared to random sampling. Some of the applications of stratified sampling: it is commonly used in market research, public opinion polls, and studies where certain population segments are of particular interest. Coming to the third strategy or the type of sampling, that is cluster sampling. In cluster sampling, we divide the population into clusters or groups based on geographic or administrative boundaries and then randomly select entire clusters to be included in the sample. Let's try to decode this. Let's say we have a use case where in India, we want to find the average weight of all the people residing in villages of India or rural areas, right? Average weight of everyone residing in the villages or rural areas in India, correct? How we would approach this problem using cluster sampling: we'll divide India into, geographically we'll divide India into the villages, all the villages that we have in India. Let's say hypothetically we have 300 villages in India. In cluster sampling of these 300 villages, instead of picking out each and every individual, what we'll do is we'll consider the overall villages as a individual or a entity, and we'll try to randomly sample, let's say 30 villages out of the 300 villages, is what is known by cluster sampling. The first thing that mentioned in the definition is we'll have groups based on the geographic or administrative boundaries. We created groups, that is 300 villages based on the geographic boundaries in India. Of those 300 villages, we randomly select the entire clusters. These 300 villages are essentially called the 300 clusters, right? Instead of selecting an individual from or a person that we did in random or stratified sampling, we'll select the entire village as a cluster. We'll do a random sampling of 30 villages of the 300, which is known as cluster sampling. So the advantage of cluster sampling is it is cost effective and practical for large and dispersed populations. As we saw, instead of sampling individuals of each of the villages, each and every person, instead of doing that, what we did is we sampled the overall clusters or the overall villages, which saved us a lot of cost, time, and it became a bit more practical when we were dealing with large and diverse population. And it can also be more efficient as compared to random sampling, simple random sampling, especially when the clusters are homogeneous in nature. If in all the villages, 300 villages that we have, the population was similar to each other, or the population distribution was same across the clusters, it would be a better option to use cluster sampling over simple random sampling. Coming to the disadvantages of cluster sampling. So cluster sampling has a potential for increased sampling error if the clusters are not representative of the entire population. Let's try to understand it extending the same example. We were tasked to get the average weight of all the people living in villages or rural India, correct? We had 300 villages in total in India, and let's say the average weight of all the people in the 300 villages was 55 kgs, right? Now we did cluster sampling over these 300 villages and selected 30 villages at random. This was a random selection. Now what happened is, of these 30 villages, let's say we selected 25 villages having high obesity rate, right? And 5 villages with less obesity rate or malnutrition because lack of resources. The average weight of people in these 25 villages, since they are prone to high obesity, let's say it is 80 kgs, and of these five villages it is, let's say, 25 kgs because they are malnutrition because of lack of resources. The overall average weight of the 30 villages would be, let's say, around 75 kgs because it will be more closer to the 25 villages, since most of the people in this clustered sample or the 30 villages, random 30 villages that we have selected, most of the people are high weight or are having obesity. Now you see the difference between what was actually the average weight versus what we got the average weight out of cluster sampling. The only reason is the clusters that we sampled out of the overall population were not representative of the overall population. This is one of the advantages, that is potential of increased sampling error if the clusters are not representative of the entire population, right? Some of the applications of cluster sampling are, it is used in epidemiological studies, social science research, and studies of population with geographic and administrative subdivisions. Coming to the fourth major type of sampling technique, that is systematic sampling. As the definition says, it selects nth member from a list or sequence of the population after randomly selecting a starting point. Let's take an example wherein, let's say, I have opened a new shopping store and I want to check, or I want to gauge what is the customer satisfaction of all the customers who walk into my store. What is the customer satisfaction of the customer with respect to my new shopping store that I have opened? Let's say the satisfaction rating that any customer can give is from 0 to 10, 0 being the least, 10 being the highest. What I do is, instead of stopping each and every person who shops from my store, I stop every 20th person, right? Starting from first, I stop every 20th person, right, to get a customer satisfaction score ranging from 0 to 10, and then I average it out. This is what is the meaning of systematic sampling, that is selecting every nth member, that is I am selecting every 20th member, first the 20th member, then adding 20, I'll select the 40th member, then going forward I'll select the 60th member from a list or sequence of population. That is, in my particular case, the population is everyone who is coming for shopping into my particular new store that I have opened, and I want to gauge the customer satisfaction or customer experience in that score ranging from 0 to 10. The advantage of using systematic sampling is it is simpler and more practical than compared to random sampling. It provides a degree of randomness while maintaining a systematic approach, right? As compared to random sampling, which did not follow any strategy or method, systematic sampling follows a methodology where it selects every nth member or the nth individual or nth item in the particular population following a certain pattern, and with this pattern it also preserves the randomness in the selection process of the sample. This is one of the advantages of systematic sampling over the random sampling. The disadvantage of systematic sampling is it is more prone to bias if there is a periodic pattern in the population list. Let's try to understand it with the same example. Let's say I have opened a new shopping complex, right? I have a new shopping complex, and what I want to do is I want to get the customer satisfaction score, right? Which ranges between 0 to 1. Customer satisfaction score means every person walking out of the shopping complex, I want to ask them of their experience, and that experience that they can rate from 0 to 10, 10 being the highest, 0 being the lowest. Now, instead of asking every person of their experience, what I do is I apply systematic sampling and I ask every 20th person to give their satisfaction score, how they felt while shopping in my complex. And what I'll do is, after let's say 100 people have given their score, I'll do an average of the customer satisfaction score. Now what happened is, in my store, since I had opened a new store, I had a policy, a marketing policy, so that saying that every 20th person that walks out of my store will get a free coupon, free gift coupon, right? Every 20th person that walks out of my store will get a free gift coupon, because it will help me market my new complex, because every 20th person will go out and say these people are giving, these are new people in town and they are giving free gift coupons, go and shop in that particular complex. Now this creates a bias while I am gauging the customer satisfaction score, because most of the people who are walking out with the free gift coupon will give me a satisfaction score of 9 to 10. The reason is because I am giving them a free gift coupon. This is what is meant by a periodic pattern in the population list. Every 20th person will give me a high customer satisfaction score because they are being given a free gift coupon. And also in my particular systematic sampling, I am only capturing the score of the 20th person, every 20th person that is coming out of my score. This is bound to increase my customer satisfaction score. The average would go higher than it should actually be. This is one of the disadvantages of systematic sampling. The applications of systematic sampling, it is commonly used in quality control, market research, and sampling from a large population where sampling frame is available. Please do not forget to like the video and subscribe to the channel for more such informative videos related to artificial intelligence. Thank you.